Hi and welcome to Talk It Do It, the channel where we like to make tech content that explores more than Hello World. Today we're building a multi-agent code review team using Azure AI Foundry and the AI Agent service. We will use the orchestrator pattern with a team leader agent that will manage all the agents for us. Here is the Azure AI Foundry Agent service page from Microsoft, and you can see it offers a lot of great functionality. You can build really powerful teams using fully AI native workflows. The link to this will be in the description, and I encourage you to go check it out. Time to get started. Let's dive right in. For this demo, I created a new project in Azure AI Foundry. Just go to the console and select the Create New button. Follow the instructions and just add your project name, resource group and region. And don't forget to add your subscription too. It will take a few minutes to set up. When it is ready, you will see a page just like this one. It's important that you copy the project endpoint, as this is used as an environment variable for our demo. In the Agents section, you will be asked to create a new LLM model deployment. We are using GPT-4o Mini for this demo. Again, follow the instructions. Just delete the agent that is created here. We do not need it, as we will create our own disposable agents. You get access to monitoring, and ours is empty right now, as we have not used this service. I will show you what it looks like when we use it. To set up our environment, we use UV to manage our Python packages and dependencies. You can use pip, but you should really be using UV nowadays. Let's also create a pyproject.toml file. And here is some example code that we will use in this demo for our team of AI agents to review. You can add whatever languages you want, and I have full instructions and code in the GitHub repository I pushed for this video. We have both Python and C# code for the demo. Now let's create a YAML file where we'll put our instructions for the agents to follow. Remember, we are building a team of AI agents for code reviews, so we want an agent per language. We are using Python and C#, but you can see how easy it is to add other agents for Terraform and TypeScript, etc. You can add your instructions to suit your use case. We also add the file types, as all this will be used by the main Python code, which you will see shortly. The UTILS Directory is important. The agent team config.yaml file defines the team coordination behavior and leadership structure for the agent team. Essentially, the rules of engagement for how agents work together, delegate tasks, and manage workflows. What does it contain? Team leader model, team leader instructions, team member can delegate instructions, and team member no delegate instructions. The agent team.py file contains the agent team class and create task function that provide the core orchestration logic for managing multiple AI agents as a coordinated team, including agent-to-agent delegation and communication. The agent team class abstracts the complexity of creating, managing, and coordinating multiple specialized agents into a single team. Without the UTILS directory, our main code would need hundreds of additional lines to handle agent lifecycle management, inter-agent communication, and task delegation. This is the current .env file used in this demo. Later you will see we add more variables when we create a tracing capability to instrument our agents. Let's dive into the agent team code review.py file. We are using the Azure AI SDK, which is a unified library that enables us to use multiple client libraries together by connecting to a single project endpoint. We are using the default Azure credential for this demo, which is our user account. And here you can see the configuration details being read from the YAML file I showed you earlier. This makes it easier to add or remove languages. We have helper functions like detect language, which maps extensions to languages, prepare code review, which formats code files with proper markdown. And here we use those environment variables for project endpoint and model deployment name. For this demo, we are using a local directory called code input. This can easily be extended to run in a pipeline against GitHub repositories, or even add an MCP server to connect to other sources of data. We have loops for iterating through the files and detecting the language, which allows us to only have agents created for files that exist and on demand. Really powerful to have such easy access to these capabilities. And here you can see how we set up our agents to use the set of instructions we provided earlier, and makes this very scalable as a pattern. Here we have the document agent and give it explicit instructions. This agent will create a report based on the review from each of the agents. This is extremely collaborative, and remember, we have a team leader agent that coordinates all of this, so we can control the sequence to exactly how we would want it. We have kept this demo quite simple for now, but clone the code and see how you can extend this to add more complex workflows. And importantly, we delete all agents. Once they have completed their tasks, there are no long-lived agents, purely on-demand and single-purpose workflows. So let's see this in action. We will run our Python file and watch both the response in the terminal and also see the agents start up in the UI. You can see all our agents in the UI, and we have a Python agent, a C# agent, a document agent, and of course the team leader agent. In the terminal we see the agent threads, and we can see it working as expected. Now all agents are deleted as the job is done. Let's go check the report and make sure it has done exactly what we asked the team to do. I do have a slight issue with format, but we'll fix that soon. Let's open this up in the markdown preview and check its contents. So far it seems to be exactly what we asked for. We can see reference to both of the languages in our code input directory, a summary overview, and then more detail for each of the languages. Looking at the C# review, it has followed our instructions and has given a good review with nice details. We can of course make this review as simple or complex as is required. We could even look to add visual graphs or an SBOM. We even get code examples. And the same with the Python review. We again get details to match our instructions in a consistent format. I like that we can see recommendations as well. Imagine using this report to send to another agent that can refactor our code and recommit. Full AI native workflows are the future without doubt. All this was done using fully automated AI agents as a team. This is a simple demo, but the potential for huge scale and complex workflows is very exciting. And here you can now see the monitoring section. With our token usage, I wanted to show you how we can instrument our code and see the traces for our agents via the UI. I will use Cursor here to add all the tracing logic for us based on a Microsoft guide. So I just passed in my prompt and a link to the guide and wanted to use Claude 4 as the LLM. Now we just get to sit back and relax whilst Cursor does the work for us. As always, do not just accept what something like Cursor gives you. You still need to understand what it is doing or trying to do versus what you want it to do. Please do not just accept everything, as this will likely cause you issues in your code. And do make sure you are working in branches, or making sure you save your work with versions. Right, now let's go check out the tracing and see what details we can see from our AI agent team. This is looking pretty good. We can see how the tracing tool is querying the application insights backend for the details. And now we can see the tracing detail for each of the tasks. I will explore this more in another video, as this is a preview feature at the moment, but this is looking very useful and would help to debug any failures or help with efficiency mapping for our agents. We can view the inputs and outputs and also look at the metadata. And worth remembering that all this is being stored in our application insights, so other tools can consume this same data. We are just using the UI for now, as this is something new. This is the end of this quick demo of using Azure AI Agent Service to create an orchestrated team of agents to do a code review. All code and instructions are in the GitHub repo that is in the description below. I want to thank you for your time today. I really do appreciate it. I hope to see you on the next video. Have a wonderful day, and thank you again for watching.